Hi students, today we are going to do a very important topic, trigonometry. Okay, this topic is very important from class 10th board examination, as well as it is going to be very important from your 11th and 12th grades, because trigonometry has an application in maths as well as in physics. So in your 11th and 12th grade, if you are not having the basic knowledge of trigonometry, you won't be able to understand many concepts from physics, right? So let us do this topic very clearly. Now today I'm going to introduce you to the basic formulas or the basic ratios of trigonometry that we have. Now when I say the word trigonometry, what does it mean? Trigonometry. Tri means three. Gon means sides. And metry means measurement. So just to put in an easy language, trigonometry basically means measurement of three-sided figure. And we know what's a three-sided figure? A three-sided figure is always a triangle. Now the trigonometric ratios are always applicable only in a right angled triangle. Okay, so consider a right angled triangle ABC wherein angle B is your 90 degree. We know the side opposite to 90 degree is always called as your hypotenuse. Okay, and the sum of all angles of this triangle is 180. That's the angle sum property. Out of that, already angle B is 90 degree. So hence your angle A and angle C are called as complementary angles, because now only 90 is remaining. So A plus C will be complementary angles. Right? Now here we have to consider which angle do we need. Okay, now we have two complementary angles here. One is angle A, one is angle C. If our angle of consideration is angle C, so that means if this is theta, our ratios are going to change according to this. Now, according to this theta, AB, okay, the side AB is its opposite side, and the side BC is going to be the adjacent sides. So now, according to this, our trigonometric ratios will change. Now, I'll tell you according to that. Now, first we have the sine trigonometric ratio. The number one that we have is sine. It is also written as sine theta. That means sine of angle of theta. It is sine is always equal to opposite upon hypotenuse. So according to this, that means if I say sine C, this is going to be, what is my opposite angle? Opposite side over here is going to be AB divided by AC. Second ratio that we have is cosine. Now cosine is also written as cos theta. Cos theta is always adjacent upon hypotenuse. So this is going to be BC upon AC. The third one we have is tan, or we also call it as tangent, written as tan. This is tan theta. So according to this, tan theta is always opposite upon adjacent. So AB upon BC. The fourth one we have is cotangent. Okay, so cotangent is also called as cot. Cot theta is adjacent upon opposite, which is equal to BC upon AB. Then the fifth one we have secant. We also called it as sec theta. So sec is always hypotenuse upon adjacent, which is equal to AC upon BC. Now the last one which we have is cosecant. Cosecant, we also call it as cosec. So cosec theta is hypotenuse upon opposite. So this is going to be AC divided by AB. Okay, so these are your basic trigonometric ratios. It is very important to know at least the first three, because if you observe, the last three are actually the reciprocals. Now next topic we are going to do reciprocals only. So the first three is very important to remember. How do you remember that which one is sine opposite hypotenuse, adjacent upon hypotenuse? So I have a shortcut to just remember. Just follow this trick. It is saw cat Soccato. S stands for sine, opposite upon hypotenuse. C stands for cos, adjacent upon hypotenuse. T stands for tangent, opposite upon adjacent. So it is going to be saw, ca, to. Now, if you remember the first three ratios, it is very easy to remember the next three ratios as well. So I'll tell you in the next slide. See, now we have reciprocals of trigonometric ratios. Now, when I say reciprocals, so let's see the first one which we had. Again, let us just mark this. ABC, this is your theta. This is your hypotenuse. Opposite, adjacent. Okay, so when I say sine theta is always equal to 1 upon cosec theta. Okay, sine theta was what? Sine theta was opposite upon hypotenuse, and what was cosec? Cosec was hypotenuse upon opposite. This goes up O upon H, hence LH is equal to RHS. So in the same way, we can derive the other formulas as well. Second one is cos theta is reciprocal of 1 upon sec theta. Third, tan theta is reciprocal of 1 upon cot theta. In the same way, fourth, cot theta is reciprocal of 1 upon tan theta. Sec theta is reciprocal of 1 upon cos theta. And sixth, cosec theta is reciprocal of 1 upon sine theta. So these are your reciprocal ratios. Very, very important, right? Okay. Now next we have some basic relationships between the formulas, relationship between the trigonometric ratios. Right, as far as the relationships are concerned, we already know the ratios and the reciprocals. So the first relationship that we can derive is the relationship between sine and cosec. So number one, we can have, as both of these are reciprocals of each other, sine theta into cosec theta can be equal to 1, because what is cosec theta? 1 upon sine. Sine gets cancelled, it is equal to 1. Second one, we can have cos theta into sec theta, again equal to 1. Third one that we have is tan theta into cot theta. Again, this is equal to 1. Just remember this, very important. Now, the next two formulas which I'm going to tell you, these are again very, very important, because these are going to be the ones which you will be using the most in your proving type of questions. So for that, we have number one, that tan theta is always equal to sine theta upon cos theta. Now, how do we prove this? Now, let us start. Now, what is your LHS? LHS is tan theta. And we know tan theta is what? Opposite upon adjacent. Now, the RHS is concerned, we have sine theta upon cos theta. Sine is opposite upon hypotenuse. Cos is adjacent upon hypotenuse. Obviously, hypotenuse gets cancelled. So what do we have? O upon A. Hence, LHS is equal to RHS. So very, very important formula. That is tan theta is equal to sine theta upon cos theta. Very important formula. Secondly, we have again the same formula for cot theta, but that will be reciprocal. Now, cot theta is equal to cos theta upon sine theta. That's simple, right? Yes, perfect. Now, keeping in mind all these trigonometric formulas, ratios, we are going to solve some questions. Right, see this now. In triangle ABC, right angled at B, okay, first of all, see, if you are finding it difficult initially, it's better to draw a simple diagram for this. So we have our triangle ABC. This is my ABC. It is right angled at B. My AB is 24. BC is 7. I don't know what is my hypotenuse is. AC, I don't know. Now determine sine A and cos A. Now using Pythagoras theorem, can I not find out AC? Okay. So, by Pythagoras theorem, we know that AC square is going to be AB square plus BC square. So therefore, AC is going to be under root of what is AB? AB is 24 square plus 7 square. This is going to be 24 square plus 7 square is going to be 625, and hence AC is root 625 is 25. AC is going to be 25 centimeter. So that means you have your hypotenuse as 25 centimeter. Right now, see, angles are changing. Your sine A, cos A, CC angles are changing. So according to the angle, your opposite and adjacent side will also change. Now for the first one, what do we have? We have sine A. Now, if the sine A, that means this is your theta. Now, according to this theta, my opposite is BC. So sine A is always opposite upon hypotenuse. So this will be BC upon AC. What is BC? BC is 7. AC is 25. Cos A. Now cos, again, A is the angle of concentration over here. Cos is adjacent upon hypotenuse. What is my adjacent? Adjacent is 24, or AB upon BC. So that's 24 upon 25. Right. The second one, it asks you about sine C. Sine C. Now your angle of concentration is this. This is your new theta now. Now according to C, which is your opposite side, it is AB. AB upon AC. Now opposite is 24 upon 25. And cos C. Cos is again adjacent upon hypotenuse. So what is my adjacent? C angle is adjacent is 7. So 7 upon, that will be BC upon AC. This is equal to 7 upon 25. That's it. Quite easy? Yes. Okay. Second question tells you, given that 15 times cot A is equal to 8, we have to find sine and sec. Okay. So what is given? It is given that 15 cot A is equal to 8. Now, can I just shift this 15 over here? So therefore, what do we have? We have cot A is equal to 8 upon 15. Right? What do we have to find out? We have to find out sine and sec. Okay. How do we do that? We know, therefore, cot A. What is cot A? Cot, we know what is the formula for cot. It is cos A upon sine A. Right. And cos A upon sine A is equal to 8 upon 15. Now, we do not know the hypotenuse, because what is cot? Cot is adjacent upon opposite. So if 8 and 15 are adjacent side and opposite side, first is the thing that we have to find out the hypotenuse. So how will you find out the hypotenuse? Using Pythagoras theorem. So let's work that out. If you see, after solving this, the hypotenuse that we get is 17. H is equal to 17. So that's easy for us to find the other values. So what is sine A? Sine A is going to be, what is sine opposite upon hypotenuse? Opposite is what? Opposite, we will take this as 14 and we will take this as, so over here, instead of going for this, we have that cot A, initially we did, no, cot A is equal to adjacent upon opposite, which is equal to 8 upon 15. So A is equal to 8, O is equal to 15. So O is your 15 upon 17. That is the value of sine A. And sec A. Sec A is going to be what? Sec A is going to be hypotenuse upon adjacent. Hypotenuse is 17. Adjacent is 8. So these are the two values. Right? Let's start the next question. The next question says that if angle A and angle B are acute angles such that cos A equal to cos B, then show that angle A equal to angle B. Okay, let us consider a right angle triangle. This is your right angle triangle. This is your A. Let this be angle B. Now this be the right angle triangle, that is angle C. Now they are telling cos A, this is given to you, cos A equal to cos B. Now according to the triangle, when I say cos A, and it is cos, so adjacent upon hypotenuse, this is your hypotenuse, so cos A will be AC upon H, that is, and cos B will be, according to B, this is the adjacent side, so BC upon H, so we can also write this as AC upon AB equal to BC upon AB. Obviously, AB being same, it gets cancelled. And therefore, what do we have? AC is equal to BC. So if AC is equal to BC, this becomes a isosceles triangle. As sides are equal, isosceles triangle, and therefore by isosceles triangle theorem, the base angle will also be equal. So therefore, angle A equal to angle B, right? Okay. So next question is, right. So they are telling you if cot theta is equal to 7 by 8, we have to calculate the value of this. Now, when they say cot theta, and over here, if you observe sine, cos, these values are given. So you need to first of all find out the hypotenuse. So cot theta is 7 upon 8, and cot is what? Cot is adjacent upon opposite. Now your A is 7, opposite is 8. You have to find out H. How will you find out? Using Pythagoras theorem. Let us try to do that. Okay, the hypotenuse that we get is under root 113 after solving the entire thing. So, and the evaluation, it has sine theta and cos theta. So first we need to find out those. So sine theta is equal to 8 upon root 113 and cos theta is equal to 7 upon square root of 113. Now let us see. Now what we have to calculate is 1 plus sine theta into 1 minus sine theta. So this is in the format of a plus b, a minus b. So can I write this in the format of a square minus b square? So a square minus b square will be, this will be equal to 1 square minus sine square theta. And in the same way, 1 square sine square theta. In the same way, we have this 1 plus cos theta, 1 minus cos theta, again a plus b, a minus b. So a square minus b square, so 1 square minus cos square theta, right? Okay. So if you observe this, when we come down to 1 minus sine square upon 1 minus cos square, we just put in the values of sine theta as 8 upon root 113 whole square and cos theta as 7 by root 113 and cos square will be whole square. So this comes down to 1 minus 64 upon 113. This comes down to 1 minus 49 upon 113. Let us take an LCM. 113 get cancelled. So over here we have 113 minus 64 and down we have 113 minus 49. So the answer comes down to, it's 49 upon 64. So 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta is equal to 49 upon 64. Now this is the question. It says 3 times cot A equal to 4. So check whether this entire thing is equal to this entire thing. So for this, we have to calculate the LHS and RHS separately. The first and the foremost thing which is given, it says that 3 times cot A is equal to 4. So therefore, can we say that cot A is equal to 4 upon 3? And what is cot? Cot is adjacent upon opposite. So we need to find out H. So we know H is equal to root of O square plus A square. So this will be your 4 square plus 3 square. 16 plus 9, that's going to be root 25, and hence h is going to be 5. That's quite simple now. So your LHS is equal to 1 minus tan square A upon 1 plus tan square A. And we know as cot A is equal to 4 by 3, reciprocal of cot A is tan A, and we know tan A is going to be 3 upon 4. And just substitute these values over here. Similarly, we can solve the RHS part. Now, RHS involves cos square A minus sine square A. Now, as we have calculated the h value, we know what is cos A. Cos A is equal to adjacent upon hypotenuse. Sine A will be equal to O upon hypotenuse. So now adjacent over here is 4 by 5, and this will be 3 by 5. So let us substitute these values and check whether they are equal or not. When we solve this, we get LHS is equal to 7 upon 25, and RHS also we get as 7 divided by 25. Okay, solve it and see it, right? So yes, this LHS is equal to RHS. That's what we wanted to prove. Right, now next, go to the next question. Right, next question says, in a right angle triangle at B, if tan A is 1 upon root 3, find the values of sine A cos A plus cos A sine C, and then cos A cos C minus sine A sine C. Okay, now tan is given, and we know what is tan. Tan is opposite upon adjacent. So let's see, tan A is equal to 1 by 3. Tan A is also equal to opposite upon adjacent. Opposite is equal to 1. Adjacent is equal to root 3. We can calculate hypotenuse. So h is equal to square root of O square plus A square, which is going to be 1 square plus root 3 whole square is going to be 3. So that's going to be root 4. So therefore h is equal to 2. Now once we get h, it is quite simple. Let us first find out the values of sine A. So for that, first of all, we have to construct this into a diagram. Let this be A. This is right angled at B, and let this be C. Now they have told tan A. So if this is tan A, this will be the opposite side and this will be the adjacent side. So for tan A, this is going to be 1 and this side is going to be root 3. And we have calculated the hypotenuse, it is going to be 2. So now let us jot down the ratios. So when we consider sine A opposite upon A, opposite is 1 upon 2. When I say cos A will be root 3 by 2. When I say sine C, this is the angle of consideration, opposite upon sine C will be root 3 by 2. And when I say cos C will be 1 upon 2. Now these are the ratios. Now we just need to put in. So the first one tells you sine A into cos C. Now what is sine A? Sine A is 1 by 2 into cos C is again 1 by 2 plus cos A is root 3 by 2 into sine C is again root 3 by 2. So what do we have? This is 1 by 4 plus 3 by 4. 4 upon 4. This is going to be 1. First one is 1 answer. Now the second one says cos A into cos C. Now cos A into cos C, that is root 3 by 2 into 1 by 2 minus sine A into sine C. 1 by 2 into root 3 by 2. So if you see the values, root 3 by 4 minus root 3 by 4, this is going to be equal to 0, right? So this is the way you will solve all your questions. Let us see one more question. So now, right, this says, in triangle PQR, right angle triangle at Q, PR plus QR is equal to 25. PQ is 5. Determine the values of sine P, cos P, and tan P. So let us consider a right angle triangle. It is right angled at Q. Let this be P. This be R. It is told that PQ is 5. So let this be 5 centimeters. And PR plus QR plus QR is going to be 25. Now let's see, let us say let PR be equal to X. So therefore QR is going to be 25 minus X. Okay. Now just put all this, let us put all these things in Pythagoras, because we know this is going to apply Pythagoras theorem. So by Pythagoras, we know that PQ square plus QR square is going to be PR square, and let us find out the value of X in that case. So I'll just substitute 5 square plus 25 minus X whole square equal to X square. So this is 25 plus 6 to 5 minus, so this is going to get expanded using the formula A minus B whole square, A square minus 2AB, so 2 into 25, so 50X plus B square, so plus X square equal to X square. So this X square gets cancelled. What do we have? This minus 50 will go over here and this will get added. So 650 is equal to 50X, and therefore X is equal to 13. That is 650 divided by 50. As soon as we get the value of X, we know what will be QR, 25. This is going to be 13. And 25 minus 13, this is going to be 12. So now just let us find out the values. So now if they say sine P, now this is my P, angle P. According to sine, this is my opposite. So it will be QR upon PR, which is going to be 12 upon 13. Cos P, again P is there, cos opposite, cos is adjacent upon hypotenuse. PQ upon PR, 5 upon 13, and then we have tan P, QR upon PQ, opposite upon adjacent, 12 upon 5. So these are the values of the required ratios, right? In this way, first of all, in order to solve questions, it is very, very, very important for all of you to remember the ratios, which is opposite upon adjacent, which is opposite upon hypotenuse, what is hypotenuse upon adjacent. All these 6 ratios should be learned by heart. Then it is very important to know which is reciprocal of what, okay? And then using Pythagoras and using the ratios, if we know any 2 sides of a triangle, we can find out all the 6 ratios. Even if one ratio is known, we can find out all 6 ratios, okay? So that's what for today. Next class, we will be dealing with identities. Again, this is the crux of trigonometry, all the trigonometric identities and the sub-identities. This is going to be the crux, the main part or the heart of trigonometry that we will be going to do. Okay, then we also have complementary angles and angles, values of some angles of specific ratios. So once we are done with identities, I'll post episodes based on those concepts as well. So stay tuned. And if you have liked my today's lecture, please do like, share, and subscribe the channel. Go through the video and try solving your questions from textbook. Thank you. That's it for today. Bye-bye.